Welcome to my YouTube channel. We want to look at surds, introductory part. First of all, we need to understand what is a surd. So a number like root 2, root 3, root 17, cube root of 16, etc. So from these examples that we have root 2, root 3, root 17, and the cube root of 16, we cannot be able to find the roots, the exact roots. So such are known as surds. So you can say that therefore we can say that numbers whose roots or cube roots cannot be obtained exactly are known as surds. So since we cannot be able to obtain the exact root of 2, the exact root of 3, the exact root of 17, or the exact root of the cube root of 16, such numbers are known as surds. We want to look at order of surds. Order of surds. What is an order of a given surd? For example, if we can talk about root 2, root 3, etc., then the order of such surds is known as the order is 2, because we have the root, the square root of 2, the square root of 3, then the order is 2. Next, if we have the cube root of 3, comma, the cube root of 5, etc., the order is 3. So the order is 3. Next, if we have, for example, the fourth root of 2, the fourth root of 7, etc., then the order is 4. So the order is being obtained. The nth root of a given surd will give us the order of that surd. So we can generalize and say that if a surd is given as n p, then the order of the surd is n. So that is the general that the order of this surd is given by the nth root. Next, we want to look at operation on surds. We want to look at operation on surds. So, operation on surds. Before we look at operation of surds, let us look at simplification of surds. The equation, the first example, simplify. We have root 24. We want to simplify root 24. 24 can simply be written as 4 times 6, and it is under the root sign, and we are able to obtain the square root of 4. So we can split the two and say this is simply the same as root 4 times root 6. The square root of 4 is 2, so it is 2 times root 6. It will give us 2 root 6. So we have simplified that. Then next, part B, we are also supposed to simplify 96. So 96 can be written as 16 times 6, that is under the root sign. So this can be written as also as the square root of 16 times the square root or root 6. The square root of 16 is 8. So this is 8 multiplied by root 6. It will give us 8 root 6. Next, root 72. 72 can be written as root of 36 times 2. And this can be split as root 36 times root 2. So the square root of 36 is 6. So it will give us 6 times root 2. It will give us 6 root 2. Next, part D, 27. 27 can be written as 9 times 3. And we are able to find the square root of 9, so we can simply say that this is root 9 times root 3. The square root of 9, it gives us 3 multiplied by root 3, so it will be 3 root 3. Part E, the square root of 16. The square root of 16 is simply 4. Then 125, root 125. So we can write 125 as 25 times 5. It is under the square root sign, so we can split and say that this is the square root of 25 times the root of 5. The square root of 25, it gives us 5, multiplied by root 5 to give us 5 root 5. So that is how we simplify surds. Next, we want to look at operation on surds. And we want to begin by looking at addition and subtraction. We can only add or subtract surds if the two conditions are met. If we meet the two conditions, then the two surds can be added or subtracted. So surds can be added or subtracted if they have the same order and the number under the root sign is the same. If the number under the root sign is not the same, and if the surds are not of the same order, then the surds are said to be in their simplest form. So the two conditions must be made for us to add two surds. That is, they must be of the same order. Number two, the number under the root sign must be what? Must be the same. Otherwise, the surd is in its simplest form. Example 1, root 2 plus root 2. The order of this surd is 2 and this is 2. The number under the root sign is the same, so we can be able to add the two surds. So maybe we can say that let a be equal to root 2. So therefore, where we see root 2, we substitute with the value of a. This is root 2. We can say that is a plus. This is root 2. We can say that is a. So a plus a will give us 2a. Therefore, our answer will be equal to 2. The value of a is root 2. So 2 root 2. And we have evaluated or added the two surds. Or you can simply say that the coefficient of root 2 here is 1 and the coefficient of root 2 here is 1, so it is 1 plus 1, which will give us 2 root 2. Part B of the question, 4 root 2 plus root 2. So the two can be added simply because 1, they are of the same order. They are of the same order. This is the surd with order 2 and order 2 because they are under the square root sign. Then the numbers under the root sign is 2 and 2, so we can be able to add the two surds. So the coefficient of root 2 here is 4, and the coefficient of this root 2 here is 1. It is the same as 1. So it is 4 plus 1. It will give us 5, then root 2. Or somebody may say that let root 2 be equal to y. Then this will be the same as this here will be 4y plus this is root 2, that will give us y. So this will give us 5y. But we have said y is the same as root 2, so answer will be equal to 5 root 2, the same as that. So next, part C, we have 2 root 5 plus 2 root 7. So let us check whether it can be added. Number one, we must check the order of the surds. The order of this surd is root 2, 2, and the order of this surd is also 2, so they have the same order. We check whether they have the same number under the root sign. The number here under the root sign is 5, and the number here is 7, so we cannot be able to add the two surds. Simply the surd is in its simplest form, so we can say that answer is 2 root 5 plus 2 root 7, because the number is different. This is 5, this is 7, so we cannot be able to add the two. Then part D, we have 2 root 7. We have 2 root 7 plus a half root 7. So we check whether they have the same order. The order here, it is under the square root sign, under the square root sign, so the order is 2, and the number under the root sign is 7, 7. So we can be able to add the two surds. So it is 2 plus a half, that will simply give us 5 or over 2, and we pick root 7. So that is our solution. Next, we have 4 part E, 4 over 3 root 27 minus a half root 3. First, we check whether they are of the same order. This is under the square root sign, so they have the same order. We check whether the number under the root sign is the same. But before that, we can be able to simplify 27. So root 27 is simply the same as the square root. 27 can be written as 9 times 3. And we can be able to find the square root of 9. The square root of 9 is 3. We cannot be able to obtain the square root of 3, so we say root 3. And we have this 4 over 3, so we can say times 4 over 3. 3 and 3 will cancel out, we remain with 4, so 4 root 3. So the first part here will simplify and give us 4 root 3, so we can write our two surds as 4 root 3 minus the second part, which is a half root 3. So since the two surds are under the square root sign, so the order is 2, and the number under the root sign is 3 and 3. So the number under the root sign is the same, so we can be able to subtract the two surds. When we subtract 4 minus a half, it will give us 7 all over 2, then root 3. Or somebody may say that you can say that this is root 3 is the same as maybe a and a. So 4a minus a half a, it will give us 7 over 2a, but the value of a is root 3, and that is our answer. So in general, to add or subtract surds, we can simply say that if you have a surd, to add the two surds, for example, the two surds in general are given as a root n plus b root n. This is simply the same as you add the coefficients of the surds, that is a plus b into root n. And if you have two surds, you want to subtract, let's say that you have a root n minus b root n. This is simply the same as you subtract the coefficient, that is a minus b into root n. Thank you guys for watching my YouTube channel. If you like my videos, you can view, you can subscribe and share. Thank you for watching.